All right, this video is on similar triangles only, not any polygon. This is just for triangles. So, there are three different ways to assume that triangles are similar, and that is by angle, which means if you have two sets of angles that are congruent in two different triangles, we all know that triangles always add up to 180 degrees, so no matter what, those third angles are automatically going to be congruent. So angle is pretty much the same as angle. Just remember you only need two congruent angles to prove that triangles are similar. The second one is side angle side. Now, not the side angle side you remember from congruent triangles. These are similar triangles. So the angles have to be congruent, but the corresponding sides have to have the same ratio. So 2 to 1, 2 to 1 with congruent angles in between. That is another way to do triangles that are similar. Last one would just be all three sides have the same ratio. That would give you similar triangles as well. So what we're going to do now is we're just going to first just say how are these triangles similar. So the hint is to redraw each one. So we have triangle ABC. That's the big triangle. And we know that this is a 90-degree angle. And the other thing that we need to do is remember that this is angle A, B, and C. Then you draw the other one. So this is AXY. So that's a right triangle. So what do you think? Are they similar? Because it looks like we have a 90-degree angle. Can you prove those triangles congruent with one 90-degree angle? And the answer is yes, because angle A is in both triangles. So technically you do have angle similarity because you do have two congruent angles since A is in both of those triangles. So the next one, same hint, ABC. So we're going to draw this guy. We have angle A, we have angle B, and we have C, and we know that BC is 4, and we know that AC is 8. And now we're going to go look at ADB. So we're going to keep A at the top, but now D goes over here, and that's going to go to B. Okay? So this B is not the exact same measure as the other one, so don't get that part confused. A BC has that big angle, and a DB, this B is only that big. Okay? So don't think that the B's are the same. Whoops. So, we do know that AB does not have a given length in here, but we do know the length of AC and BC, which are not taking place anywhere in here. But we know that AD is 2. Okay, so you've got a whole bunch of stuff here, and you're trying to figure out, is this actually, do we have enough information to say that these are similar? So think about that for a minute. I don't see enough information, do you? So we know we have angle A. Okay, so we've got that. We do not have enough other information, so no, they're not similar. So that's one of the things you have to look at. Like I said, the trick is thinking that B is similar or is going to be congruent to that by angle. But like I said, if you look at this angle B from this triangle and the other one was the big one, those are technically not the same angle that time. And that's one of the things that goes back to chapter 1 where you're really careful. There are 3 different angle B's over here. So that's why you have to be careful when you draw your picture. Name similar, if any. So you have 2 triangles in this one. And again, I'm going to emphasize the fact that you should always redraw these to see if you in fact have similar triangles. Because when we get to the algebra part, you might be better off redrawing. So we know that AM is 2, and we know that AB is 6. So we're going to have a 1 to 3 ratio. And the bottom is 4, and this is 12. 4 over 12 is definitely going to be 1 to 3. And then finally we have 3 and 9. So yes, they are going to be similar. Their ratio is going to be 1 to 3, and the names is triangle AMN is similar to triangle ABC. All right, there you go. Next one. We talked about this in the last video a little bit. We have something that looks like the hourglass. We do have parallel lines, so remember, A is going to be congruent to E, B is going to be congruent to D because of alternate interior angles. Those angles are going to be congruent because of vertical angles, so yes, triangle ABC is similar to triangle. That would be EDC, and that's going to be by angle-angle similarity. These are congruent by side-side-side similarity. All right? So that's just the basics of similar triangles. Now we're going to get to the fun stuff. Now we're solving for x. Now, before you get excited and say, oh, these are going to be easy, yeah, this one is easy. This is just going to be 3 over 6 is equal to x over 8. That's it. All you have to do is top over bottom is equal to top over bottom. And that's going to give you 3 times 8 is equal to 6 times x for cross multiplication. 24 is equal to 6x, so x is equal to 4. Now that's just a shortcut. You technically did not use similar triangles to do that. So this is what I'm talking about. If you look at the 3, that's part of a triangle. If you look at the 6, that's part of a trapezoid. That's not a triangle down there. So that only works if you're doing triangle and or top part over the bottom, top part over the bottom. That does not work for this example right here. Because if you did 3 over x and 4 over 16, I'm telling you right now you're going to be wrong. Because that is the bottom of a triangle, and this is like the bottom of a trapezoid, and stuff like it. That's not going to work, okay? Because 16 is also the bottom of a triangle if you look at the big triangle. So remember when I said draw? Here we go again. Draw the similar triangles. This technically wasn't similar triangles. It does work. That's pretty much the shortcut. The real way to do this one would have been 3 and x, and then the big triangle would actually be 9 over x plus 8. Now, I'm telling you right now, you'll get the exact same answer, so you don't have to worry about it. But when you have like a side and the bottoms, you must draw the separate triangles. So this is 3 and 4, and this guy is x plus 3 over 16. And then you go to work. So you just have to do your 3 over x plus 3 is equal to 4 over 16. Cross multiply, and you are going to end up with 4x plus 12 is equal to 48. So 4x is equal to 36. So x is equal to 9. And you are good to go. So you get to try the next one. Make sure you redraw. Or if you can redraw it in your head, that's fine. Just make sure you set up the correct ratio. So we have 2 over 3 is equal to x over 6, if you did that correctly. Because remember, you have the little one, 2 and x. You have the big one, which is 3 and 6. So you cross multiply, and you're going to end up with x is equal to 4. Okay? So that's the little triangle inside of a big triangle. Remember to draw. It's only a shortcut if you're just doing left and right sides. If you throw the bottom into the mix, you cannot do that. Okay, so these hourglass problems. Notice how the first two do not have any parallel lines. Now, I'm going to skip to the last one because we've already talked about this before. When you have the parallel lines, you know they just switch. So this goes here, and this goes here. So we have x plus 6 over 16, and we have x plus 2 over 8, giving us 8x plus 48 is equal to 16x plus 32. And then all we're going to have to do is solve for that. So that's going to give us 8x is equal to 16, so x is equal to 2. But in the first two, we do not have parallel lines, and you are not allowed to assume it. So how are you going to figure out, does 3 go on top of 6 or does 3 go on top of 12? Same with the x, does it go on top of 12 or 6? What you're going to do is you have to use the third set of sides. So the top and bottom pieces, they have to go together. So we have a 4 and we have an 8. So we know the ratio needs to be 1 to 2. So is 3 over 12 1 to 2? No. Is 3 over 6 1 to 2? Yes. So this is an example where they just go straight down. So this is just a triangle that's been flipped over the vertex point. This is not a little twist where you have alternate interior angles. So for this guy, we're just going to say 3 over 6 is equal to x over 12 because they have to keep the 1 to 2 ratio. And then you just have to cross multiply here, and you're going to end up with x is equal to 6. Okay, same thing in the middle. Do you crisscross or do you just go straight down? So think about that for a minute. You need to crisscross because 5 over 15 is going to give you a 1 to 3 ratio. In order to get a 1 to 3 ratio, you need to do 3 over 9, not 3 over 12. So you're going to have 3 over 9 is equal to x over 12, which means you are going to end up with 36 is equal to 9x, giving you x is equal to 4. All right, so that's it with some similar triangles and some fun algebra problems. Remember, it is always safer to redraw the two triangles when you have the little triangle inside of the big triangle. And when you have hourglass problems, remember to check to make sure the ratios are the same if you do not have parallel lines. If you have parallel, you know right off the bat these guys are switching sides. All right, this is Longo and I'm out. See you, bye.